Okay, we discussed about how to create different objects in SSAS in our last sessions, and today we are going to discuss about how to write MDX queries to pull data from SSAS cube database. And MDX stands for multidimensional expressions, and MDX is a querying language to query data from SSAS cube databases. Let's see where you can see the cube what you deployed first of all, deployed and processed in your in a server. For that you have to go to SQL Server Management Studio, and here you can see different server types, and in that you have to select analysis services and give the local server name where you have your cube database. In my case it is localhost. I can give localhost or simply dot and click on connect. And under databases, you can see different databases we deployed and processed in this server. I deployed only one database, that is sample project, and in that I have one cube, that is AdventureWorks, with 5 dimensions and 1 measure. Let's see how to write MDX query and where I have to write MDX queries in order to pull data from your cube database. Okay, for writing MDX queries, before going that, let's see whether you can browse data, cube data from your SSMS, that is SQL Server Management Studio. In order to browse your cube from Management Studio, you have to right click on the cube and click on the browse. You can see similar browser kind of option that you have in your bits environment. Here you can select whatever the measure you want. These are all the measures that I have in my cube. Let me take the sales amount here. And if I want to see year wise, I can drag calendar here into my rows, and what month of a particular year, you can drag and drop month into your columns. Okay, this is how you can browse the data of the cube in SSMS. And let's see how you can write query, MDX query, and what's the syntax you have to follow for MDX query. For that, you have to open Query Analyzer window page. For that, you have to click on the database and click on New Query. Here, this is the page where you have to write MDX query and execute and see the result. Before going to that, in MDX query, there are two important concepts, that is two important things, that is set and a tuple. MDX is completely dependent on this set and tuple. Whatever the query you write, you have to make use of any one of these or both. Okay, what is a set and what is a tuple? And one more thing is hierarchy order. We have two things in a dimension. One is attribute and another one is hierarchy. Let me drag in, and you know about hierarchy. Hierarchy has, one second. Hierarchy is nothing but a data which you can see in hierarchical in nature. It's a default view that the user wants to see, or a particular set of attributes in a particular organized order that a end user wants to see. For example, if you see category, subcategory, and product, user wants to see his data, his sales amount, his stock category, subcategory, and product. In that case, these three attributes will form a hierarchy, and each attribute in the hierarchy we call it as level. Let's go to the bits again, and let me create and show you what's the difference between hierarchy and an attribute here. Let's say, for example, I'm creating a hierarchy for year, quarter, and month, and this is my hierarchy. Okay, and each attribute that is part of this hierarchy are called as levels. Okay, if I process this, Let me process this. Okay, I processed it and it's successful. Let me drag this one. Let me. Okay, this is my hierarchy, and I've given the name hierarchy. If you can see it here. The name of the hierarchy is just hierarchy. I didn't modify it in it. Modify it so it is showing as hierarchy, and these are all the levels. So for example, if you drag calendar here, I can see three different set of items in one when I drag this hierarchy. One is bin time, second one is hierarchy, and third one is calendar year. If you split this one into three, here, let me copy this. I'm splitting this one into three. The first one is dimension name. And second one is hierarchy name. And the third one is level. Okay, when you drag a level from hierarchy, then you will get all these three. I mean, this is how you can name a hierarchy. You can when you drag and drop a hierarchy, you will get all these three items. This is how you can represent a hierarchy. You have to pass the dimension name, hierarchy name, and the level. Which level you want to see. For example, in my case, I want to say calendar level data. So hierarchy representation, a level from a hierarchy. If you drag a level from a hierarchy, then it represents like this. It has three items. One is the representation should contain the dimension name, the hierarchy name, and the level. What level you want to see. In the same way, attribute is also a hierarchy, but with default two levels. One is all and another one is members in it. For example, if you see here, this is my dimension and this is my hierarchy name. And if you see, these are my levels. I have three levels here. And when you see an attribute, this is my dimension name and this is my hierarchy name, let's say. And these are my levels. One is all level and the other one is the members level. Okay, I can see all level here. Under that, all the members are there. And the other one is just members. So what I'm trying to say here is each and every attribute in a dimension is a hierarchy, and with default two levels. One is all level and another one is the members in it. Okay, let me take you here and show you. I process this view. Now this is the hierarchy. What are the levels that I have? All level, under that year level. The first level is all aggregated top level, and the next level is what I selected here is year and quarter and month. So it is showing years, and under that months, under that under that quarters, under that months. So it has 1, 2, 3, 4 levels. But I've different three levels here, but the default one that it takes while processing is all, that is the supermost level of the hierarchy. In the same way, if you select any attribute to see, it has all level and the members in it. The second level is members in it. So it has two levels, one is all and the members in it is the second level. So this is how it looks when I drag and drop a hierarchy level. How it looks when I drag and drop an attribute. Let's say I'll drag this year. So this is how an attribute can be represented. If you see, even this one has three different parts. One is the first level is dimensions, that is dimension name. Second level is the attribute name, we will call it as hierarchy name here. And the third level is again the attribute name. That is level. So this is how an attribute is represent. You can represent a attribute and a hierarchy. If you want to use a hierarchy, if you want to see the data of a level from any hierarchy, then you have to use like this. You have to give like this. And if you want to see attribute level data, it's a dim time, that is dimension name, and the attribute name, and again attribute name. The first attribute name says that that is hierarchy level, and the second time if you repeat the same attribute name, that is level. Okay. And here 3 points that you have to keep in mind. One is even every attribute is a hierarchy itself with default 2 levels, and the other one is in dimension, in a high level, the dragging and dropping a level from hierarchy, you will get the syntax like this: dim time dot hierarchy dot hierarchy name dot level name. Whereas in this one, it is dim time dot attribute name, but it is not attribute name, it is hierarchy name and it is level name. So whenever I say the level of the attribute, then it will be a calendar year. Whenever I say a level of the hierarchy, then it's same as the attribute name here, what I have given here, but the hierarchy name changes. The hierarchy name is unique for a hierarchy, and it is same as the attribute name for attributes. Okay, why I am telling all these things? You are gonna make use of, in every query you are gonna use only these two items, either attribute levels or hierarchy levels. This is called a hierarchy level and this is called attribute level. And one more important thing, one more important concept, that is sets and tuples. Before going to that, what are members? Members, sets and tuples. Okay, what are members? Members can be under hierarchy level. Hierarchy level means this one, or attribute level, this one. If you see under attribute calendar here, I have 4 members. These are my members. And if I see under calendar, I can see the same 4 members, and these are called members. The members of each hierarchy level or attribute level, those are members. And if you see what is set, if you drag and drop members from same hierarchy, then these are called a set. Set means collection of members from same hierarchy. Here hierarchy doesn't mean that you are dragging from same calendar here. The hierarchy means, what is hierarchy? Until this is hierarchy. How you will refer a hierarchy here? This is called hierarchy, dim time dot hierarchy. And this is called level, dim time dot hierarchy dot calendar year. In the same way, this is hierarchy, dim time dot calendar year, and dim time dot calendar year is level of the attribute. So if it has same hierarchy, that is, if you see 2001 has same hierarchy as 2002. When two members are having the same hierarchy, or if you take some collection of members with same hierarchy, then this is called set. And you can represent set by copying the members into a flower bracket separated by comma. Okay, this is how you can represent a set. In other words, in syntax wise, if you want to see, it's a flower brackets, member 1 from hierarchy, comma member 2, comma member 3, comma, and so on. The point here is all members should be from same hierarchy. This is why I explained about the concept, how to differentiate whether it's from same hierarchy or whether it's from different hierarchy. Okay. If you see, the advantage of having hierarchy here is, the first thing, If I drag and drop year, and when I drag and drop the month from here, can you call it a set? You cannot. Why? Because these two are having different hierarchy levels. The hierarchy level of this one, the January member, is dim time dot English month name, whereas 2001 member hierarchy is dim time dot calendar year. If you create a hierarchy, I created a hierarchy name hierarchy, and I'm dragging calendar year, that is 2001, just like the same what I dragged in. And when I take calendar month, let me drag this. You see, until the hierarchy it is same. Until the hierarchy level it is same, and hence we call it as a set. This is one advantage of having hierarchies. This is not the major advantage of having hierarchies, but this is one advantage. Okay, going forward you will come to know, we're going to cover about the advantage of having hierarchies. Okay, this is tuple. When you have more than one member, but all the members from the same hierarchy, then that is called as a set. Okay, what is tuple then? And the set, you have to represent that one in flower brackets. This is set. What is tuple then? When I have members from different hierarchies, or collection of sets, you can call it as. Let's see example for both items. I'm dragging 2001, comma, I want to see the data for year for the member 2001, and let me drag from the attribute rather than dragging from hierarchy, comma, I want to see some March data. So if you see the hierarchies of these two items, this is dim time dot English month name for March member, and for member 2001 it is dim time dot calendar year. So this is these are two different members, from two different hierarchies. So this is called as set. And how to represent the set? You can represent in round brackets. So this is, I'm extremely sorry, this is tuple or tuple. Okay, tuple is nothing but collection of members from different hierarchies, or collection of sets. For example, you can take set also. I want data from 2001 and 2003. So this is from same hierarchy, and I can make it as a set. And in the second case, I want data from March and February and May. This is one more set, that is May of months. Okay, so this is a tuple, and this is the major difference between the set and the tuple. In simple, set is the collection of members from same hierarchy, and tuple is collection of members from different hierarchy, or collection of sets is also called as tuple. Okay, this is about sets and tuple. Why we discussed about the sets and tuple is we are gonna use this in every MDX query. Okay, now let's come back to MDX query. What's the syntax of MDX query and all. The MDX query syntax, it is not on columns. It is not select staff from the table name and all. The syntax for that one is select either set or tuple or simple member on columns, comma, the same thing, on rows, comma, and so on. You can go for pages. It's multi-dimensional one. It's not two-dimensional. You can go for any number of dimensions from cube name. Sorry, from cube name where any condition if you want to give. And what is this I've given and so on. For on columns means it is on columns, on rows means it is on rows. What the third one is called as? The third one is called as pages, and the fourth one is called as sections, and the fifth one is called as some paragraphs or so like that. That's the names given by them, and there are no names for. I mean, the names are given up to 5 levels only. After that, there is no names given to see this multi-dimensional data. But all the MDX queries, whatever you see, it will be stick to only columns and rows. Why? Because our systems are not capable of showing the data in many dimensions. You can see the data in only 2 dimensions. Our systems are not ready yet to see multi-dimensional data. We have to see the data output in multi-dimension. So you can see MDX queries until columns and rows. And if you want to give, if you want to know what are all the other access that you want to give, that is, you can simply call as either columns are 0, rows are 1, we can call it as 2. You can define the access here, 8, 3, and so on. And so on. Okay? But you're not going to use this 2, 3, 4, or 5 or null access. Why? Because our systems, the systems are 2-dimensional, and it can show you data in only 2 dimensions. And what is access here? The axis means it's an x-axis or y-axis or z-axis kind of. If you want to see the data in the data, what we're going to get from cube is multi-dimensional one, and each dimension, each one, the columns is an axis here. How you want to see data? It's an axis. It's 0 axis or 1 axis. You can define. You can give it as axis 0, axis 1, or axis 2, and so on. Okay. Each dimension, how you want to see the data, is called an axis. Let's see a simple example, simple query. What's the simplest query that you can write in MDX? That's the question people may ask you when you are in the interviews. So let me tell you the simplest query that you can write. Select from cube name. This is the simplest query you can write. It will fetch you some data. And no one knows what the data is, but it is showing you some data, 26427624. And there is no column heading for that. So it will give you some default measure value. When you don't specify any axis, your 0 axis or 1 axis or 2 axis, you have to define your axis. 0 axis is columns here, 1 axis is rows, and 2 axis is pages, and so on. So if you don't give any axis information, then it will pull the data from your cube, the default measure data, and it won't display any value, any column header or row header for this. It's just a dummy data. And okay, this is giving you some measure data, but you don't want that measure data. You want to see a particular measure. Select from adventure works. You can write where to see some order quantity data. Okay, give me data, but it should be where order quantity. I don't bother around showing the rows, or whether it is not my row, it is not my column, and I want to see order quantity data. If you run this, it is showing you order quantity. This is the order quantity that is there in the sum of order quantity from the table, past table, but it is not having any rows and columns. Okay, how do you want to see this data in axis? Before going to that, you can give any number of axes, but let's take that we can give only 2 axes. Why? Because your system doesn't support multi-dimensional view of output. So let's see how the syntax will be for 2-dimensional one. It is select, set tuple or something on columns. You can define the same as 0, or you can represent the same as axis of 0. I'm not sure whether it's flower brackets or round brackets. I think it's round brackets. And the next one is rows or 1 or axis of 1. And there is no comma after the last axis from cube name. This is the syntax if you want to write MDX for two-dimensional axis. So let's see. And it is it should be in sequential order. Without having axis 0 or axis, column axis, you cannot give row axis. And let's see an example for that. I don't want where condition. I want to see this order quantity on columns and find out the difference between having the order quantity in where condition and order quantity in columns. So it is giving you the order quantity and the value of the order quantity, the column order quantity and its value. And as I said, it should be in sequential. The axis should be in sequential. You cannot have an axis 1 without having axis 0. Let's try that one. I'm giving rows directly without having axis 0. Axis number specified in a query must be sequentially specified and cannot contain gaps. So the axis number 0 is missing here. So that's why it is throwing this error. And let's see. Let me take this one as columns and let's see whether it's running fine or not. It is running fine. It is giving me order quantity, and you can have many measures, not one measure. You can have more than one measure, and you can have dimensions here. And let's try to add one more measure. What will be the measure? If I add one more measure here, I have to separate with comma separator. And let me take the sales amount. And if you see this order quantity and the, sorry, I dragged order quantity again. I have to drag sales amount. Okay, the sales amount and the order quantity are having the same hierarchy, that is measures. So it will become a tuple, a set form. So I have to represent this with flower brackets. Set means same hierarchy. Tuple means different hierarchy. And let me execute this. And I'm getting my order quantity and the sales amount here. This is how you can have more than one measure in your call in any of your axes. Now it's not mandatory that you have to have measures in columns and dimensions in rows. You can have measures in rows and dimensions in columns, like that. And let's try to add the row. Let's try to add the row axis too, which is specified in the syntax. So what I have to do? First I have to add a comma separator, not separated, comma, to differentiate between the columns and the rows. And let me try to add a measure again. Let me add tax amount. I'm trying to add one more measure on rows. And there is no comma after rows, as this is the last axis we are going to give. And if I try to run this, it will throw error. Why? Because the measure, if you see the error, the measures hierarchy already appeared in the axis 0 axis, which means this is the hierarchy. Up to here, this is the hierarchy for measures. For dimensions, you will have a dimension name, measure name, hierarchy name, and level name. You have three sets in one representation. But here, for measures, it is only measures the hierarchy name. So if you have a hierarchy defined or used in one axis, you cannot use the same hierarchy in other axis. So if you see here, the measures is used in columns and the measures is used in rows. Let me go back here, and in the same way, if I apply the same to a dimension, then I cannot use dimension 2 to this member in rows when I'm using the second member in columns. Why? Because both will have the same hierarchy. And if you see, let me drag it here. So what it is saying is I cannot have same hierarchy in two different axes. So what I have to do is I have to change the hierarchy here. Instead of taking any measure item, I will take a customer. So if I drag up to this is up to hierarchy level. What I will get if I take up to hierarchy level, the member in the hierarchy level. Okay, this is the member in the hierarchy level. These are all the members in the hierarchy level, that is all. So it is giving me all data. What I have to get the members level? I have to go till level. As I told you, this is your dimension name, this is your hierarchy name of the attribute, and this is your level name of the attribute. If I give till level, then I will get all members on that, like this. So this is how you can, this is the simplest MDX query with the two measures in columns axis and one attribute on your row axis. And is it like this that we have to have only measures on one axis and only dimensions on other axis? No, it is not. We can have dimensions and measures on one axis, and if you have dimensions and measures on one axis, in the other axis obviously you can have different dimensions apart from whatever you used in the first level. So let's see here, I will try to add an year attribute and key calendar year. I'm taking up to level. Sorry, let me go here. Let me remove this syntax for better view of the query, and I'm taking comma separator. So if you see the hierarchy up to here, this is dim time dot calendar year is the hierarchy for the level what I drag, that is calendar year. And for these two, the hierarchy is measures. So these two will form a set, but these three combinedly will form a tuple. Why? Because these are two different sets, I call as. So this is one level one, this is a different hierarchy level, and these two different hierarchy level. These two hierarchy level is measures, whereas for this one it is dim time dot calendar year. And if you see the formula for tuple, it is collection of sets. This is one set, the first one is one set, and the second one is one set. So I have dimensions in my columns as well as in rows. But if you see the dimensions hierarchy level, for this one it is dim time calendar year hierarchy, and for this one it is dim customer name hierarchy. Both are not same, and then you, that's the mandatory condition that you should not have the same hierarchy levels in two different axes. This is how you can see the data. This is year level 2001, you will have both order quantity and sales amount. And for year 2, both order quantity and sales amount. It is cross joining. For every year, I have 4 different years, and for 4 years, it is giving me order quantity and the sales amount. So for 4 into 2, it will be 8 columns. And the rows is, as usual, the customer name. So this is how you can use dimensions in both the columns and rows. What you have to make sure is the same hierarchy is not repeated. Okay, let me see by giving the same hierarchy here. I'm giving only 2001 here, which will give me 2001 year data. Okay, this is coming correctly. And here I'm adding 2002, which means it is same hierarchy that is there in the columns and in the rows. But what this one will form, this is of two different hierarchies and hence this is a tuple for me. So let me keep it in round brackets. Now it is going to throw error. Why? Because the calendar hierarchy, it is giving a clear information. The calendar hierarchy already appears in the axis 0 axis. So here the calendar year of hierarchy is already used in axis 0, and again I am trying to use it in axis 1. So you cannot have the same hierarchy in two different axis levels. So whenever I say about hierarchy, the thing that has to come for in your mind is the first two items of the representation, or except the last item of the representation. Both means the same. And let me run the query again. I removed the hierarchy, the calendar hierarchy from the rows, and it is executing properly. But you can see so many nulls are here. I have only some set of rows, but if you see the total number of records that it fetched, it is 10,656, among which many are null records. Do I need to show this null? What's the information that it is going to give to the end user? I mean, in most of the cases, if you see among the 10,000, there is only data for 1,000 customers also. The remaining are null. So how to hide this null data? You can use a function called non-empty, non-space empty function to customer name. What it will do is, if I give the non-empty to a row item here, then it will come here, it will check for this row, for every row, whether all the measures are null or not. Okay? If there is a complete null, then it will remove that record from that output, the output record set. Okay? Let's see, there are so many nulls, and let me run this one. And you can see there is no null records available now. And you can see the total number of records that is there, it is just 586. So this is how you can remove nulls. What will happen if you add non-empty to your columns here? What it will do is, it will take each and every column. If the complete set is null, the complete column is null, then it will remove that column. You will have data like this in few cases. Let me tell you an example where you can see this kind of data. I'm taking this year out and pasting the year here. Just I'm not doing anything, I'm just interchanging the dimension, the hierarchy that we use, the dimension attributes that I used in rows and columns. Okay, now I have customers in my columns and years in my rows. Let me remove the non-empty here again. Run the query. This will fetch me 4 years data. And it will take hell of time. Why? Because for every customer, 2 measure values. So I have 10,000 plus customers, so 10,000 into 2, something around 20,000 columns will come here now. If you see, it is still executing. It is going to take hell of time. See here, this is the output. For a particular year, it is not showing properly. Let me drag this here. For a particular year, for every customer, you can see the data. Like this. And let me take a data for only year 2001 and see how it looks. Still, even it is for 2001, it is gonna fetch all 20,000 columns, so it is gonna take time. So if you see, there are so many columns. Let's see how many columns are there. 21,309 columns, which means for every customer, the order quantity and the sales amount. Like that for every customer. Why? Because I interchanged the hierarchies that I used, the attributes that I used in rows and columns. So now let me give non-empty to my columns here. So this column is completely null. Only one record is there, that is null. And the same with this column, for this customer the sales amount is null, for this customer the order quantity is null. There are so many null. And let's see how much time it took, 29 seconds. And it is gonna fetch, it fetched me 21,309 records. Now let me rerun the same query by adding non-empty function. It took just only 1 second and it fetched me 1,169. That is for each customer is two measures data, that is order quantity and the sales amount. Okay, now let's see. We're getting all members data, and this is not the ideal way of seeing your output, like the customer name on the rows, on the columns, and year on the rows. Let me change this customer, pull this customer name into my rows and this year into my columns, and let me add non-empty. Year-wise order quantity and sales quantity of each customer is my target, and let me run this. So I'm getting this data. Fine, everything is fine. And how I want to see the aggregate data, if I want to see the aggregated data, for example, all the customers data. Okay, this is my 500 customers data. And sorry, what if I want to get the sum at the end? So for that, you know how to get all records, all aggregated data. Let's say if you remove this, it is going to give you all level data, that is hierarchy level data. So what you have to do is the simple, just add the things again. This one will give you aggregated data, and if you drag the same at level of the attribute, then it is going to give this one. The output of this one, if you run this query, it will throw you an error. Why? Because the customer name hierarchy is used more than once in the cross join. So this is one time I used, and this is the other time I'm using. So the same hierarchy, it should be a set. So if you are using the same hierarchy, then you have to define it as a set. So now this is aggregated level data, the top level data, and it is individual customer level data. And Sometimes the user wants to see, if you want to fetch and display the records at the bottom instead of showing on the top the aggregated data, simply interchange these two. It is going to give you the exact result that you're expecting. Okay, and go to the end. It is giving me aggregated level data. This is about non-empty function and how to use attributes and all. Okay, let me do one thing. I have here I have two attributes. What will happen if I give only dimension name instead of hierarchy and all, hierarchy level and all? It is going to throw me an error saying that the customer dimension contains more than one hierarchy, therefore the hierarchy must be explicitly specified. Which means, if you see, this is the customer dimension what I have given as part of my MDX query, and when you specify just MDX, when you specify just the dimension name, then it is getting confused which one to select, whether you are asking to show the customer key or the customer name. If you have only one dimension instead of two, then it is not going to ask you. Let's demonstrate that one. Let's see how it's going to work. Let me take the customer. Here, instead of two attributes, I am removing one. This customer key, I'm making it as customer, and I'm going to make use of the property name column. The key column will be the key, and the name column I'm going to give name. So the name that I want is customer name, and let me process the queue. Now in my customer dimension, I have only one measure for which the name column is customer name and the key column is customer key. This is called single attribute dimension, and let's see how it is going to work if I give only hierarchy name. Here, only dimension name. Here I'm running the query again. I have only dimension name here, but still I'm getting the data. It is giving me hierarchy level data. Okay. Now, let's see. Let me give the customer level name. I'm giving up to here. I'm using the syntax up to hierarchy. If I run this, it is going to give me all level data. One second. 0 rows. So here, sorry, actually I changed the dimension name and all. So what I have to do is I have to refresh the cube. Actually, this is not my dimension attributes name now. So that's why it is throwing error and it is not giving any result. Now if you see, this is my customer name. This is my customer at the hierarchy level. So let me run this. It is giving me at hierarchy level. We can call all members. Before going to that, let's see what this member function gives. The members will give the members in that particular hierarchy level. That is, this one will have a blanks and all. So it is giving all the members, including the all. If you want to fetch all details, all the members, under that particular hierarchy, including all, then it will give you have to make use of the members function. If you use the same members function for a level of the attribute or hierarchy, for a level, this is the level. As you know, this has three different parts. One is the dimension, and second one is the hierarchy. The third one is level. To represent the attribute up to level, then if you use members, it is going to two members under that. Let's see the difference between the current one and using the members up to hierarchy level. This is your hierarchy level. Under that, if you see the members, you have all members, and under that you can see the names of all the members. And if you see on the level, you can see only the members under that, not all. This is how the members will give the at level of an hierarchy or the attribute. You don't need to specify the members function. Why? Because by default it will show you the members. If you run this. Like this. Okay. Now let's see how to. I don't want to see all the customer data. I want to see only one or two customer data. Two customers data. For example, let me see. Let's say I want to see only John V. Young's data. This is, if you drag and drop this John V. Young data, it is showing you some number instead of the name John V. Young. And it is the key column. Why? Because we are using only one attribute, and the attribute key reference is key column, customer key, and the name column is customer name. So when you represent any attribute or any member with ampersand, then that you are referring to a key column. If you run this one, it is going to give you John V. Young data. If you remove this ampersand and if you run the same, it is not going to give you any result. Why? Because it will search in the name column instead of key columns. If you add ampersand, then it will search in the key column, and in the key column it is customer key, and customer key 11000 exists for John V. M. If you don't add this, if you add this, and if you try to refer with the name here, name column 1, John V. and it is not going to give any result. Why? Because there is no key with the name John V. And similarly, if you remove ampersand and if you have a different key column, then it is not going to give the result. Here what you have to refer it without having ampersand in the syntax is, you have to give the name column item value, that is John V. Young here. So this is how you have to represent the key column and the name columns. And let's say I want to see the data of more than one member, that is John V. Young and some other name and Gabriel Hill. I want to see three members data, and three members belongs to the same hierarchy, and hence it becomes my set. So I have to keep all these items into a flower bracket, and let me run and see. This is how we can see the data of three members. Okay, we work on hierarchies, attributes till now, and let's see how to use hierarchies in MDX queries. Let me remove this time calendar. I have only two measures now, and Let me use a hierarchy hierarchy member calendar level, calendar year level. So if you drag this level, calendar year level from the hierarchy, and if you see the representation, it is dimension name and the hierarchy name and the level name. Then this, now it is giving me different level, that member level, different members that belongs to that particular level, and its order quantity and the sales amount. Now, let's see a typical requirement. I want to see months on columns and sales data like sales amount and order quantity on columns and year on rows. So let's see how to achieve this kind of requirement. I want to get months on columns and year on rows. Now, for this, let me copy the same query, and I'm going to the new window, and order quantity and sales amount is the measures that I want to see, and I want to see months on columns. This is as per the requirement. Okay. Now, calendar year, I want to see in my rows. If I use attributes of the dimension for achieving this requirement, it works fine. If you use hierarchies for this requirement, you have to make use of attributes. Why? Because you have to make sure that the same hierarchy is not called in two different axes columns and axis rows. If you use hierarchies, what the problem is, if you drag and drop month name here from the hierarchy, then if you see the hierarchy of this, it is dim time dot hierarchy, and if you drag year into the rows, then it is calendar year dim time dot hierarchy dot calendar year. If you try to run this, it is not going to give you data. Why? Because the dim time dot hierarchy is used in two different axes. So to achieve the requirement like this, like months on one axis and year on one axis, or in other words, in generalized way, if you want to see two different attributes of the same dimension in two different axes, then you have to make use of attributes rather than hierarchy. And I have one more requirement. I want to see sales data, order quantity and sales amount, and I want to see rows, calendar year and month on rows. In that case, before going to that, let's see how to add multiple dimensions, multiple attributes into rows or into any particular axis. Till now, the queries what we have seen, we used only one attribute in one axis. Let's see how to use multiple attributes. Okay, now let's see how to add two different dimension attributes into same axis. Okay, let me take the same query and I have two measures on my rows and the hierarchy dot calendar year. Let me replace this one with the attribute, that is calendar year here, and let me take one more measure, year wise, let's say product data or product category data, as product data is too huge. Let me take year wise product category data. As these two are from these two have two different hierarchies. One is having the kind of calendar year as hierarchy, and the other one is having the product category as calendar name. These two forms is a tuple. So that's why I've given it in long brackets, and this one should be. If you run this, it's giving me 2001 bytes, 2002 bytes data, 2003 accessories, and 2003 bytes data, and 2003 close data. Whatever the data that I have, I don't have data for few things, and this non-empty is filtering the data, the null cells. If you remove that and see, you'll get the data for all the years and all the process. It is cross-joined. So I don't want to see the null values here, so let me use this non-empty. And non-empty will filter all the rows that are if the complete row is null, it will filter out that, or the complete column is null, then it will drop the data for that particular column. Now this is how we can use two attributes in same access. In this case, we used calendar year and calendar name on rows. And now let's see the requirement, new requirement. I want to have calendar year and calendar month on the same axis. That is the row axis here. So what I have to do is, this is year, the first one is here, and the second one what I have to use is calendar month, that is English month name. So as these two are two different hierarchies, you can give like this. So you can use, and let's say this sometimes the requirement comes like this. You want to show 2001 data under that all the quarters. Let's see. Let me show you an example how that one is. some sales, and January under that, February under that, March under that, and so on till December. After that, 2020 is like year and month on same column. So if you want to fetch the data like this, these two should be having same hierarchy. It should be set instead of tuple. Tuple means you will get the data in two different columns. It is two different hierarchies, so it will come in two different columns, whereas if it is a set, then it will come in the same row. For example, this is tuple, two different columns. You can see the data in two different. And what is set? Set is nothing but having the same hierarchy. Let's say calendar year of 2001 and calendar year of 2002, these two forms is set. So when I run this, you will get these two into same column. Even though I am using two different, these are just members. So how to achieve the kind of requirement like the year and the months into one column? So to achieve the requirement, the first thing is these two should form a set. So these two, if you wish to form a set with two different attributes of the hierarchy, attributes of the dimension, then you have to make use of hierarchy. So in hierarchy, you will have the same hierarchy level. For example, let me remove this and show you by dragging the year and month from hierarchy. Here is the hierarchy level is hierarchy here, and I'm dragging month, and the month level is hierarchy level is hierarchy. So these two items levels from a hierarchy forms a set instead of tuple. And if you use the same items from attributes list, then these two forms a tuple. Let me run this. If you see, it is giving 2001, 2002, 2003 and 2004 and all the month-wise data under the years. Okay. Now, this is about how to use hierarchy members, hierarchy levels, and attribute levels, and hierarchy levels and attributes levels as tuple and sets. Till now, what we discussed how to use attributes and measures and form a tuple, and how to form a set with measures, and how to form a set with hierarchy members, that is calendar year and calendar quarter, sorry, English month name of the hierarchy, and how to form a tuple and use the tuple in same axis, in axis rows, which is formed with two different attributes, that is calendar year and English month name. And the main thing that you have to remember, the key point that you have to remember from this session is, the first thing, you cannot have the same hierarchies in a tuple. You cannot have the different hierarchies in a set. And you cannot have the same hierarchy in two different axes of the MDX query. Now let's go forward and see different functions that are available to fetch the data from your analysis services cube database as per your requirements. Okay, let me take up to here. This query is what I want, and let's start a fresh window, and the data that I'm going to see is up to here, this data. From now onwards, I'm going to play with hierarchies. Why? Because the functions make more, functions, you need hierarchies. For example, you will come to know, let's start and discuss about few functions, and at the end you will come to know about how these hierarchies and the functions are related, and why these functions are useful only when you are using hierarchy level items. Okay, if you take up to hierarchy and if you give members, it will give you the members. What are all the members that are there? It will give the complete hierarchy structure. The complete hierarchy structure, in other words, if you see here, this time, this is the hierarchy what we are using, and the process, let me reconnect, and this is the hierarchy. Let me hide this to get more space. It has all level data and year level, quarter level and month level, and the same follows for all the members of the different levels. If you see here, I just given hierarchy dot members. It is given all the year and the semester and the quarter and the 3 months, and again the quarter and the 3 months, and next the new year started. So it is giving me complete hierarchy. Okay, this is fine. This looks good for me. This is one of the requirements for me. And if I want to show only year level data, what I will do, I will pull the hierarchy dot calendar year, and the hierarchy, up to hierarchy we have members, and it is giving me all the members, and up to level, if I use level also, I have members. If I use members, it will give me the members that are there in that particular level. Okay, now up to here it's fine. What about a member? If I drag a member from here, from a year, let's say this is a member, all these are members, I'm dragging member 2002. Will this one have members? So if you see this, the members will not have members. Members will have children. So if you run with children, what will happen is it will give the children of this 2002. The children of this 2002 is nothing but the children, the next level members of the member what we have specified in the query for the function. This is why I said the functions, these functions need hierarchies. It will make much use of hierarchies. Why? Because if you use the same children, and let's see by giving the same children function for an attribute level. And the attribute of calendar here is this one. This is a dimension name and hierarchy name and the level name, and I am giving children for this. And children functions expect, I have to give a member, not a, let me give 2002 like what we have given there. If you see here, it is giving nothing. Why? Because attribute has only two levels. One is default all level and the members level. You can, if you give children, if there is nothing to display the data. So that's why these functions make much full use of, we can make much use of these functions when we are referring to hierarchy levels. So let me go back to the hierarchy and let me take the year 2002. Let me remove this class brackets. I don't need this anymore as I'm not using anything set here. Dot children will give me the next level data of this particular member what we specified. Okay. Now let's discuss about few more functions using which you can pull the data in different ways. Different kinds of data which is very difficult to pull using normal MDX queries. Okay. This is fine, it is giving me 2000 year next level data. So this is 2002 and next level data is 1, 2, 3, 4, that is 4 quarters. What if I want to see the next level data instead of, if I pass 2002 as input, I want to see the month level data. In that, what I have to do? Shall I go with children.children? Children.children will throw an error. Why? Because the children will expect only one member. For example, if I am the parent and if I have 10 children, if you ask me a question like root-based children.children, that is grandchildren, then it is not going to give you any result. You have to specify any particular parent to give the children. This function is not grandchildren. It cannot become a grandchildren like this. Why? Because it doesn't know how many children are there for this and how many grandchildren are there, so it won't give you that. So to achieve that requirement, you have a function called descendants. So let's see how to make use of descendants to achieve the function that if I pass the year, I wish to get the month that belongs to that particular year. So I think this is the spelling, descendants of, you have to give the member and the level. So what is the member here? Member means, in this case it is 2002. What member grandchildren you want to see and what is the level you want to see. Let me implement the same for this one, the query that we are using. So I'm using descendant function. Give me descendants. If you open bracket, it will give you what are all the possible ways you can make use of this function, what are the parameters that you have to pass and what will the output. So you have to give the member and what is the level. The level that I'm expecting here is if I give calendar quarter, and let me close this. If you give calendar quarter, then it will give you the data up to calendar quarter. Instead of calendar quarter, our requirement is we want to show month level data. So if I give English month name, then it will give me 2002 year month level data. So the syntax is damn simple. Descendants will give you the descendants data of the member whatever you specified here and the level that you specify. So give me the descendants of 2002. What descendants? I want English month name descendants. So if you see the hierarchy, this level 2002 member descendants of English month name. In the same way, if you provide 2001, you have only 6 months data in 2001, I guess. So it will give you that 6 months data. So this is how the descendants work. Instead of giving the level name, you can specify the number, level number. It will give 0. It will start from 0. Sorry. The 0 means the same one what we have given as input, the member. That is 2001. So give 1, then it will go 1 down level, that is quarters. It has 2 quarter data, that is 3 and 4. And if you give 2, it will give 2 levels down, that is months in this case. And what will happen if you give 3? If you give 3, it will not return anything there as there is, sorry, that's the end, so it is giving the last level data again and again, as there is no next level after level 2. And there is one more parameter for this. If you wish, you can pass this parameter. Let's say I'm giving 2 or 1 I'm giving. What will be displayed here? It will give me the quarter level data. And that's the first level. This is 0th level, this is the first level, and this is second. This is 0th level. Why? Because the member belongs to that level. If I have a quarter member here, that is first quarter of 2001, then this will become the 0 level. And this one will become the first level. So this is giving me the first level data, that is quarters here in this case. And you have a few more functions that you can add, that is self. If you give self, it will give you the self data. Oops, 1 second. So it will give you the self data. Self means the member level, whatever we specified in the second parameter. And you can give and underscore before. Means give me self and before data. Self means the self belongs to the level 2, that is quarter, and before is the year. So it will give you year and quarter data. Self, and you can give after. This one will return you quarter data and month data. It is just like pure English. If you know English, you can understand what is quarter data. What are all the possible things that you can do as part of the third parameter is self and after, self and before, just before, just after, and you can have so many like this. It's a combination of these things. You can give the previous items and you can give the next items, and you can, if you give before, it will give all the levels before, and if you give after, it will give all the levels after. I'll show you an example for before. Sorry, after. If you give 0, what will it display? It displays, sorry, it displays 0 means it refers to the same year, and after means it is giving all the levels after that. That is quarter and month in this case. This is how you can make use of descendants to go to navigate to the next level or the later level or any level that is next to the member what we specified as part of the first parameter. And let's see one more function, interesting function. Okay, now children will give me the next level data, and descendants will give me the level that I want. I can navigate to any level that I want from the member what we have given, that is the member in this case is 2001 of calendar year. Now instead of this, let me remove this dissonant function. I'm not going to use this. There is one more function. For example, I'm dragging some month. There are so many months. Each month belongs to some year. I don't know which one belongs to what also. Let me take this September, and you can see the complete hierarchy here, 2003, 3 and September. And I'm adding dot parent. Dot parent is a very interesting one. If you run this query, it is going to give me parent. September belongs to the third quarter, and it is giving me. I don't want the September data. I know I'm in September month now. I want complete quarter data. So how I can get that? If you use dot parent function, it will take that to one level up, and it will give you the September level, so that particular quarter level data. Where you need these kind of functions. Let me tell you an example. I have, for example, I have an attribute. The attribute has 10 members, like 10 different colors or 10 different countries data. Okay, each country is having 10,000 sales. Each country, 10,000, 10,000, 10,000. Now they want to calculate the percentage of sales when they come for each country when they compare to the overall sales. The percentage will be just 10%, as it is 10,000. Total into 10 will become 1 lakh. 10,000 of 1 lakh is 10%. So let me show you an example. Here in Excel, if you take, these are my products, prod 1 to prod 10. On prod 11 I got, I can delete one. I have 10, 10, 10, 10, 10. I have 10 rupees sales of each product. If you want to calculate, how you will calculate? And you will have all members when you have an attribute, and all member will give you 100. So for calculating this percent, this, that is the product value, is equal to this divided by this. Here all is nothing but parent. So what I'm going to do here is the product, the particular product divided by the parent of the product. So it will give me the percentage, that is 0.1 into 100, that is 100%. So in that case, I can make use of parent function. And if I want to navigate back to a particular parent, and if you want to see the total parent sales, in most of the cases, people love to see the data like this. Okay, a particular manager has 10 employees, and 10 employees are performing well, and what the percentage of his sales when compared with other 9 employees. Who is standing on top, and what's the percentage? Okay, if you see the order by data, you can see the top person, but the percentage of this particular person when compared with overall 10%. So in that case, you can make use of this parent function. And how, if I want to get the data of this particular year that belongs, that this September belongs to, I drag a member, and dot parent is giving me next level. And what will happen if I take one more dot parent? It will navigate and it will show me the year level data. This September belongs to third quarter and 2002 year. And what will happen? This is year level data. And what will happen if I go for one more parent? So it will take me to all levels, that is the aggregated level, top level of the hierarchy. What will happen if I go for one more parent? It will take me to nothing, because there is no other parent for all. Why the parent is going fine and the children is not going fine? The parent, for any member, there will be only one parent. It's taken from our real life one. For any parent, there will be only one. Sorry, for any member, there will be only one parent. For September, one parent, that is XYZ, and XYZ will have one parent, that is ABC, and ABC will have one parent that is IJK, that will be, and like that it will take feedback. Okay, this is fine, this is working fine, and I can go to any level. What if I have 50 levels in my hierarchy? How I have to go for dot parent, dot parent, dot parent? I have to give from last level. So if I want to go 25 levels up, then I have to go with the function. If I use parent function, then I have to go like this: the particular member dot parent, dot parent, dot parent, dot parent, dot parent, like this. So is there any function that will be, similar to the descendant function, which will help me to take back to a level that I want, I wish. There is a function that is descendants, and the syntax is, that is ancestors, that is syntax is similar to descendants. Ancestors of, you have to give the member and the distance. Distance is nothing but you can give either 2 or level. If I give 2, which is taking me 2 levels up, that is year in this case. Or you can give the level name directly, just like you have given in descendants function. So this is how the ancestor works, and ancestors is opposite to the descendants function. And there is one more function, that is ascendants. It pronounces very close to descendants. It looks like it will give you a feel that it is opposite to the descendants, but the opposite to the descendants is ancestors, not ascendants. The ascendant function, I will show you how this ascendant function works. I'm writing, and the ascendant function don't want any level or any distance. It wants just a member from the hierarchy. If I pass any member from hierarchy, it will take you back to the first level. It will give the complete data about this particular one. This is the member I have given. This member belongs to this quarter, and this quarter belongs to this year, and this year belongs to this all aggregate hierarchy. So this is the advantage, but the only disadvantage is, what if I want to see only one level? I don't want to see all levels up. I want to see only one level up. In that case, you have to make use of either parent function or ancestors function. So this is how this is the difference between ascendants, descendants, and ancestors function. Now let's see how to see the brothers and sisters of a particular member. Okay, let's take the same example. I have September month. I want to see the brothers and sisters of this. Who are our brothers and sisters of this particular function? How can I get the different members? Make use of the existing functions we discussed, and if you see all the functions that we covered till now, if you want to see the brothers and sisters, which means brothers and sisters means these parents' children. So this parent will give me the parent of this one, that is quarter 3, and if I go back to children, then it will take me to the children of this one. So it will give me September to August and July. So this is how you can get the brothers and sisters. This is one way of getting brothers and sisters of a particular member. And there is one more straightforward function. Instead of going back and coming forward to get the children of the parent, to see the brothers and sisters of a particular member, whatever we have given, the function called, the function name is siblings. So it is again a pure English word. If you know the meaning of siblings, and if you give the siblings, it will give you the same result as parent or children, that is siblings, the brothers and sisters. And what about to get the first brother of your, if you brothers are 3, and if you want to get who is the eldest one, then what the function you are going to use is dot parent dot first child is there. T child will give the first children of the particular member. So it will go back to the parent, it will go back to the third quarter, and we come back saying that I don't want all the members, all the children, I want just first children. Or simply you can use first sibling. Parent or first child is equal to first sibling. And similarly, if you want to find out the last member, you can make use of parent dot last child. It will give you the last brother or last sibling, or in other words, you can make use of last siblings. Who is the last of the sibling? It will give you the last of the sibling. This is how you can navigate, and you can find out the children's brothers and sisters, and the first child and the last child of the hierarchy. Now, let's see about the range function, how to give and how to make use of range function. For example, if I have 10 years data and I want to see from 2001 to 2007, then what I have to do, I have to make use of a set and I have to specify all the members in the set. Let's see, I don't have 10 months data here, sorry 10 years data here. Let me show you an example with 2 years, for example from 2001 to 2003. If I want to show you, then this is how I have to keep all the members into a set. As these belong to the same hierarchy, I have to keep all these three into one set, and this is how I can see. What if I have more than 10 items and if I want to specify 5 to 6 in my set? So it will become lengthy. Instead of that, you can make use of the function that is range function. You have to specify the first one, colon, the last one. The meaning of this one is it will start from the first one and it will give the data till the last one. That is the range you are specifying, the start one and the last one. So it's your wish. You can make use of functions and you can see, for example, let me show you an example how to use functions that we discussed to give the range. I'm taking July, I don't know what is this July, dot first sibling starting from first sibling of July month to last sibling of July month will give me some range. I don't know how many items will fall into this, but it is a range function. You can make use of range function. It will give you the particular range. It has 3 items. The first sibling is August and the last sibling is September, October, and it will give me this data. You can use any function to give range, like to get this data, to get this information of many members, instead of creating using all the members in the set. Okay, there is one more function to go back. See, I have seen, we discussed about how to get the first children and the last child. Now, what about how to get the next brother that is next to you? For example, if I am 7th one and if I want to show you the 6th, then what I can do? I cannot use first sibling, I cannot use last sibling. Then the function that will help me is lag or lead. Lag or lead. If I give lead of 1, it will take me 1 member forward. That is September. If I give lead of -1, It will take me one number back. And remember, it doesn't bother about the hierarchy. Your father is the same person or not. It will check for the members. If I give 11, it will take me back to the 11 members. There is no members, 11 members before this. If I give lead of 11, it will take forward by 11 members. Where you will use this? For example, if I want to see the sales difference, the variance between current month and 12 months back, which means the same month last year. So I will use these numbers, July divided by, or July minus, same July dot lag of 12 or lead of minus 12. Lead means will take you forward if it is plus positive number. It will take you back if it is negative number. In the same way, lag means it will take you back if it is positive number and take you forward if it is negative number. So negative lag is equal to positive lead and negative lead is equal to positive lag. This is how you can go back to a particular number on forward. And you can use one more way to get the next number, that is next member. Is a function which will take you one number forward. And if you want to go forward by one more number, you can give one more next number. This is just like parent or parent or parent. Instead of that, you can use ancestor there. Instead of these, you can use either positive lead or negative lag. And what about going back to the previous number? It is pre-member. It will take you back to previous number and you can give any number of previous members. And for example, the example what we discussed earlier, that is current month minus last year same month, I cannot write dot previous member for 12 times. That one will degrade the performance. Instead of that, I can make use of lag of 12 or lead of minus 12. It will take me to the same month. So this is how you can make use of previous member and next member functions and lead and lag functions. And you can use range using lead or lag. For example, this July, this is 2001 July. Let me go back. Let me say this is 2012 July, and from here to dot lag of 12, which means I'm asking you to go back 12 months back. Starting from that, I want lag of minus 12 or lead of 12. I can use whatever I want. Okay. So I have to get 24 months data, that is starting from, and July should be the middle of this one. This is July, it will go back 12 months here and it will go forward 12 months here. So this is how you can use the range functions in this one. And discuss about many functions now, like previous member, next member, lag, lead, and parents, children, descendants, ascendants, ancestors, and all. Okay, let's discuss about one more thing. I know this is the starting, this is the ending point, that is July 2002 to 12 months forward is my end point. If I don't know the starting point, I don't know whether I have value or the lag of 12 or not. I mean 12 months before to this particular July of 2002. In that case, if I want to get the data from starting point to the end point, in that case I can use null as the starting point and the ending point will be July, 12 months next to the July of 2002 as per this query. So in that case, it will start from the starting month and it will take me till 12 months after July. That is the next July. This is the July 4, 5, 6, 7, 8, 9, 10, 11, 12. So like this, you can make use if you don't know the starting point. And for example, if you know the starting point, that is July of 2002, and if you don't know the end point, you can make use of null to start from 2002 July to the end point of this one, of the member of the attribute hierarchy level or hierarchy level. But you cannot use null is to null forget all the members in the node. Instead of that, what you can do? You can simply use, you want to get the months, right? You can simply use the English month name. It will give you the full members present in that particular level. Okay, and let's see how to show the products, and let's see about one or two useful functions. That is, I'm taking products here. I have something around 131 products, but I don't want to show all the products. I just want to show only 5 to 10 products for testing or reference purpose. Then I can make use of these functions. Head of level or tail of level. So you have to pass any level, attribute level or hierarchy level. Now in this case, this is attribute level. So I give head of, sorry, I have to give the number here, like 10 or some number, whatever the number you want. Let me give head of 15. I want to show top just 15 products. I don't bother whether it's top or not. What's the number I've given? 1, 2, 3, 4, 5 products are shown. Just a second. Okay, this is because of non-empty. It is pulling me 15 records or 5 records, whatever. And the integer number I have given as the second parameter, but because of non-empty, it is going invisible. Let me give 15. If I want to get 15 from starting of the products, it won't bother whether it's the highest sales or highest quantity. It bothers. It will take the top 15 products. That's it. Whatever the products that are there in the list of 15, it will display that. Whatever the number you give, it will display based on that. In the same way, as it is ascending order, it is taking top 25 or top 15, whatever I am getting here. And if you make use of tail, if you use tail, then it will give you the last 25 or some n number of products that you are asking for. These are the last 25 in this case. You can see the result set. It is showing as 26. Why? Because the column occupies one row. That's why it is showing. This is how you have to use tail and head functions to fetch the top rows, top 5 or top 10 kind of rows. Okay, it is just top data, top products. It won't bother about whether these products are having highest sales or not. You have different functions to get the highest sales products, top 5 highest sales products and bottom 5 highest sales products and all. But this is just to pull the top 10 or top n number of records or bottom n number of records from of a product or of any attribute. Okay, and let's discuss about few more functions in the next session. Till then, bye.